This is lesson 4.6. It talks about, and its objective is 0 and negative exponents. It's very important for us to know that there are negative exponents and there are positive exponents. And there are different rules we're going to be seeing according to 0 exponents and negative exponents. All right, this is a small activity just to get you to know the 0 and negative exponents. If I have 2 to the third power, it means 2 times 2 times 2, it gives me an 8. 2 to the second power, 2 times 2 is 4. 2 to the first power is actually 2. And then I start off with the 2 to the power of 0. If I look at the answers, from 8, for it to become 4, what did I do? I divided by 2. From 4 to become a 2, again I divided by 2. How do I find 2 to the 0 exponent? Again I divide. 2 divided by 2 is actually a 1. So the number 2 to the 0 exponent is a 1. And then I move on. If I divide 1 divided by 2 again, because that's the pattern, 1 divided by 2 is actually 1 over 2. So 2 to the negative 1 power is 1 over 2. And then I have 2 to the power of negative 2. What do? Again, I divide by 2. 1 over 2 divided by 2 over 1. I cannot divide fractions, becomes a multiplication, so it's 1 over 2, and I flip-flop the second fraction times 1 over 2, which is equal to 1. 2 times 2 is 4. So my answer is 1 over 4. What happened? Any number to the power of 0 is a 1. Any number to the power of a negative is always in the denominator. We're going to see through the examples. But this is a nice activity for you to try on your own. 2 to the third power, try it out. 2 to the second, 2 to the first, and then put your question marks and try finding them out. Once you're done and you understood the concept, it's easy to understand the examples that are coming. Okay, the main rule for this lesson is any number to the power of 0 is equal to 1. Any number to the power of a negative exponent is 1 over the number with its exponent. Usually I need to rewrite them using positive exponents. Always remember, I'm going to give you a trick here. If in the numerator the exponent is negative, bring to denominator, it becomes positive. This is number 1. Number 2, if it's in the denominator, exponent is negative, bring to numerator. What do I mean? Any number that's in a numerator with a negative exponent, if you bring it down to the denominator, it becomes positive. Any number with a negative exponent in the denominator, if you bring it to the top in the numerator place, it becomes positive. It's a vice versa thing. It's just like taking things from top to bottom and from bottom to top. Let's see the first question. Write using positive exponents. Once they say using positive exponents, I do not need to simplify. I simply keep the number with its exponent. Number 1 says 3 to the power of negative 5. Because this is a numerator, it's actually 3 minus 5 over 1, it becomes 1 over 3 to the power of 5 positive. I cannot keep the negative. Because it's in the numerator, I bring it down to my denominator and it becomes 1 over 3 power 5. Let's look at the second example. M power 0, n minus 4. The first thing I do is I break them up. What does this mean? M to the power of 0 times n power negative 4. What is any number to the power of 0? It gives me a 1. Just like the rule, any number to the power of 0 is equal to 1 times n power negative 4. It's in the numerator. What do? I bring it down to my denominator. Any number with the power of negative, I put it 1 over this number with the exponent. 1 times 1 over n4, what does it give me? It's actually 1 over 1. I multiply 1 times 1 is a 1 over 1 times n to the power 4 is 1 over n4. And that's my answer. You have to be real careful in this lesson. It's a bit tricky. Let's look at the third example. First thing I do, I separate. This means 16 times x minus 6 times y. All of them in the numerator. Where is my variable with the negative exponent? This. So I put it over 1, I bring it down. So my answer is 16 times y over x power 6. Because I took my x to the denominator, it becomes positive exponent. I leave the rest as they are as long as they do not have negative exponents. So actually my answer is 16y over x power 6. Why did I ask you to separate them? Open them up for you to see where the negative exponent is, to which variable, where is the 0 exponent, so that you know exactly how to solve each step. We're still writing using positive exponents. Number 4 says 3y negative 2. First thing I do, I separate them. 3 times y power negative 2. This is in my numerator. I need to make it positive. I leave the 3, I do not touch. I bring it down as it is, and I bring this to my denominator, which is just like this. I interchange it. Once it's the numerator, the exponent is negative, bring it to the denominator, it becomes positive, and vice versa. If it's in my denominator and I bring it to the top, it becomes positive again. This is simply my answer. I am only rewriting things as they should be. Let's look at number 5. The first thing I do, I separate them. This means a minus 7 times b to the third. Where is my negative exponent? It's with the a. So a is my denominator. So it becomes b3 over a7, and that's my answer. Just bring it down to my denominator, nothing more, nothing less. The next question is, write without using a fraction bar. What do I mean? I mean I need to take off my fractions. So any denominator, I need to take it to the numerator. If I take the c3 to the top, what happens? If the denominator is negative, bring it to the numerator, it becomes positive. And if the denominator is positive, you take it to the numerator, it becomes negative. So my answer is a2c minus 3. As simple as that. I leave the a2, I bring the c to the top. Because it's positive, it becomes negative. If it was negative, taking it to the top would make it positive. Let's see the second example. Number 7. Again, I need not to use a fraction bar, yani no fractions. I need to take this to the top, 2a minus 8. Because it's positive, I took it to the numerator, it became negative. If it was negative, I take it to the numerator, it becomes positive. Okay? The same thing here. I need to take this to the top, it becomes x7z minus 2. So actually we're gonna just do a wrap up of the rule. But we still have questions to go through, okay? At the end I'm gonna wrap it up, but now let's move on. The third type of question is, find the product, which is multiply, or the quotient, which is divide, using only positive exponents. Again, I'm only going to be using positive exponents here. I have to find an answer. I cannot leave, like number 9, 5 to the power of 10 times 5 minus 6. When we multiply, what do we do to exponents? We add exponents if they're similar. And when we divide, what do? We subtract exponents. So this rule in lesson 4.5 is with lesson 4.6. They're both together. Here I have the base number as a 5 and I have multiplication. What does multiply mean? I add the exponents. So it's 5, 10 plus minus 6 because there's a negative 6 here. I don't change signs, which is 5, 10 minus 6 plus and a minus give me a minus. So my answer is 5 power 4. How did I do that? Multiplying same base numbers, I add the exponents. So it's 10 plus minus 6 plus and a minus give me a minus. So it's 10 minus 6. So it's 5 to the power of 4. Let's look at number 10. 8 n power negative 3 divided by n power 2. When I'm dividing, I'm subtracting the exponents. What do I do before that? I bring the n negative 3 to the bottom. It becomes 8 over n3 times n2. Why did I do that? They want only positive exponents. What do? I leave the 8 as it is. n3 plus 2 because it's multiply. It's n5, so it's 8 over n5. Look at these two examples. They're a bit tricky, but if you know the rules, at the end of the tutorial, I'm going to review with you all the rules you need, okay? So here, what did I do? I got the n negative 3 to make it positive to the bottom. So it became n3 times n2. Both of them have the same base variable. So it's n power 3 plus 2 because it's multiplied becomes an n5. We're still using the same question, find the product or the quotient using positive exponents. I have an a minus 2 times an a 10. Because it's multiply, I add my exponents. They're the same base number. So it's a minus 2 plus 10. So it's a 8. Is it positive or negative? Positive, yes, I got the question correct. Look at number 12. It's b minus 4 divided by b minus 6. What do? First thing is I change them to positive. It becomes b6. Denominator goes up to the top, becomes positive. Numerator goes down to the bottom, again becomes positive. And now, because they're the same base number and it's division, when I divide, I subtract exponents. So it's b6 minus 4, which is b to the second power. Is it positive? Yes, it goes with my question. Number 13 is 2 minus 3 over 2 to the fourth power. What is the first thing I do? I change any negative exponents to positive. I bring this down here. What goes in the place of? It becomes 2 to the third times 2 to the fourth. There's no numerator. What do? I just put a 1. And now they have the base numbers similar. So it's 2, 3 plus 4 because they're multiply. It's 2, 7. So actually the answer is 1 over 2 to the 7th power. Is it positive? Yes, it is. So just leave it as it is. Let's look at the last example I have. 5k3. The first thing I told you, split them up, separate them. 5 times k to the third over k minus 9. Where is my negative exponents? It's in my denominator. What do I do to it? I bring it to my numerator. So it's 5 times k3 times k9. Here, same base numbers. They're multiplying. What do? I simply add the exponents, which is k12. So my answer is 5k to the 12th power. As a wrap-up, always split or separate to solve correctly. Any numbers you have with the variables, split them up so that you see which is negative and which is positive. When I am multiplying the same base numbers, I add the exponents. When I'm dividing same base numbers, I subtract the exponents. Any number to the power of 0 is equal to 1. If the numerator is negative, take it to the denominator, it becomes positive. If the denominator is negative, take it to the numerator, it becomes positive, and vice versa. So if, and let's say, numerator positive, take it to denominator, becomes negative. One more rule, if I have denominator positive, take it to numerator, becomes negative. Guys, this wrap up is what lesson 4.5 and 4.6 is about. So if the numerator is positive, take it to the denominator, it becomes negative. And if the denominator is positive, take it to the numerator, it becomes negative. So it's a vice versa thing. Please, guys, go back and review these rules. As you go along, check them out. Re-see your tutorial, okay? When the denominator is negative, take it to the numerator, becomes positive. When the denominator is positive, take it to the numerator, it becomes negative. When the numerator is negative, take it to the denominator, it becomes positive. When the numerator is positive, take it to the denominator, it becomes negative. It's vice versa, okay?